Hey guys, how's it going? It's John Spindler here, and tonight I'm going over Virtual Router Redundancy Protocol. A little bit about what I'm going to do tonight is a little bit different from what I've been doing. A lot of people think of VRRP as just like HSRP, they just made a complete carbon copy of it, and as long as I know HSRP, I should be good to go. From a configuration standpoint, it's not too far off, but as far as the protocol goes, there are some key differentiators that you should be aware of. And because I didn't know it as well as I wanted to make myself believe I did, I wanted to spend some time to go through the actual RFC and try to find out for myself what is the big difference. Are there any differences I should know with the configuration or how the protocol operates in the back end, and try to identify those differences. Obviously it is pretty similar to HSRP, but since it is a different protocol and it is on the CCIE blueprint, I figured what better time than to dive in and show you guys what I find out along the way. So before we get started with the actual CLI, I wanted to just pull up the RFC, and matter of fact, I've already pulled it up, and I wanted to just go through it with you guys and maybe we can learn something together. So here it is, the IETF RFC 5798 for Virtual Router Redundancy Protocol, version 3 for IPv4 and IPv6. So it says this memo defines VRRP for IPv4 and IPv6. Goes through like a nice little index of all the different stuff. Let's see here. So this might be boring, guys. If you guys want, you guys can just skip right ahead, but I know a lot of people are probably like me and they don't want to read the RFC, so maybe they'd rather have someone sort of break it down and they can just listen to me talk. So it says there are a number of methods that an IPv4 end host can use to determine its first hop router towards a particular IPv4 destination. These include running or snooping a dynamic routing protocol such as RIP or OSPF. Running a dynamic routing protocol on every end host may be infeasible for a number of reasons. The use of statically configured default route is quite popular. It minimizes configuration and processing overhead on the end host and is supported by virtually every IPv4 implementation. As you guys know, since the HSRP videos that you've probably seen, hopefully you've checked them out, that's a big red flag there, and I can already hear it screaming. Is how do you deal with that loss, or that packet loss in the event of an ISP failure or a northbound layer 2 failure. So it says here, VRRP is designed to eliminate the single point of failure inherent in the static default routed environment. VRRP specifies an election protocol that dynamically assigns responsibility for a virtual router to one of the VRRP routers on a LAN. The VRRP router controlling the IPv4 addresses associated with a virtual router is called the master and forwards packets sent to these IPv4 addresses. The election process provides dynamic failover in the forwarding responsibility should the master become unavailable. So quickly we can identify there's some changes in the terminology. So here it looks like the active gateway or the active router is now called the master, and the standby in the case of HSRP is now called the backup, right? So pretty close. Just some change in wording. We're not going to go over IPv6. It's kind of out of the scope of this video, and probably out of the scope of how I'm going to spend my time studying. So it goes through some definitions here. The VRRP router is a router running VRRP. Pretty straightforward. As you start to dive into these, they get a little less intimidating. This one actually isn't that long, so we'll probably just move right along. A virtual router is an abstract object managed by VRRP that acts as a default router for hosts. Okay. IP address owner. The VRRP router that has the virtual router's IPv6, so 4 or 6 addresses as real interface addresses. So this was interesting when I first read it, because I was like, what are they talking about? And we'll get into it in a little bit, but there's the notion that the actual virtual IP address that we set up in between them would actually be one that's actually one of the actual addresses on one of the physical routers participating. So we'll get into how that sort of affects the VRRP election here shortly. But pretty interesting, because throughout my studying up until this point, I literally thought, router 1 had to be .10, router 2 had to be .20, and the virtual IP had to be something that neither of them shared or owned in this case. So that was pretty interesting. We'll look into that a little bit further here in a couple of minutes. The primary IP address. In IPv4, an IPv4 address selected from the set of real interface addresses. One possible selection algorithm is to always select the first address. In IPv4 mode, VRRP advertisements are always sent using the primary IPv4 address as the source. Okay, so this is talking about, on that physical address, where is it being sourced from? So being sourced from the primary address. The virtual router master is the router that's assuming the responsibility of forming the packets. So the one that wins the election. And everyone should be pretty sharp on how the general functionality of this stuff works by now. The backup is the IPv4 address backup. Backup of an IPv4 or 6 address or addresses is the primary function of VRRP. While providing election of a virtual router master and the additional functionality described below, the protocol should strive to minimize the duration of black holes, right? We saw that in the HSRP videos, if you guys check that out, where if we don't do some additional configuration, these protocols don't have any sort of intelligence as far as what's going on north of the stack. So there's some additional enhanced object tracking that can be tied to the protocol to give it some sort of intelligence as far as the election goes. So that was one of the benefits. We want to minimize the steady state bandwidth overhead and processing complexity, function over a wide variety of multi-access LAN technologies capable of supporting any IP traffic, 4 or 6. Allow multiple virtual routers on a network for load balancing. So probably in another video we could go over the specific use case and design and configuration for that. But essentially you would have multiple segments going on between, say, 2 routers, and each router would be active for a certain portion of the southbound LAN or the end hosts. So some sort of load balancing could be achieved by sort of splitting the hosts that are pointing to one as active versus another. Let's scroll down a little bit. So it gets into some subsecond operation. We've talked about that. It says subsecond detection of master VRRP router failure is needed in IPv4 and IPv6 environments. Earlier work proposed that subsecond operation was for IPv6 only. This specification leverages that earlier approach for IPv4 and IPv6. One possible problematic scenario when using small VRRP advertisement intervals, right, speeding up that conversation, may occur when a router is delivering more packets onto the LAN that can be accommodated, and so a queue builds up in the router. It's possible that packets being transmitted onto the VRRP protected LAN could see larger queuing delay than the smallest VRRP advertisement interval. In this case, the master down interval will be small enough so that normal queuing delays might cause a VRRP backup to conclude that the master is down and therefore promote itself to the master. Wow, that's interesting. Very shortly afterwards, the delayed VRRP packets from the master cause a switch to backup status. Furthermore, this process can repeat many times per second. So it's very interesting that you're reading this RFC, you think it just talks about the protocol, but it actually gives you these warnings ahead and gives you these considerations to take into account before you start going buck wild with the timers and trying to speed things up as fast as possible. So let's keep moving on. VRRP overview. VRRP specifies an election protocol to provide the virtual router function described earlier. All protocol messaging is performed using IPv4 or IPv6 multicast datagrams. Thus, the protocol can operate over a variety of multi-access LAN technologies supporting IP multicast, right? A virtual router is defined by its virtual router identifier. And this is important, guys, because we'll see earlier, we'll see later when we start diving into the packet structure. This is pretty important when we do packet captures and stuff. You'll be able to see the virtual router identifier sort of peek its head out in the packets, so keep an eye out. It says a VRRP router may associate a virtual router with its real address on an interface. The scope of each virtual router is restricted to a single LAN. A VRRP router may be configured with additional virtual router mappings and priority for virtual routers it is willing to back up. The mapping between the VRID and its IP whatever addresses must be coordinated among all VRRP routers on a LAN. So everyone's got to agree. Everyone's got to be on the same page. This shows you a little bit about the configuration, the sort of deployment. I'm sure you guys can sort of enumerate from my topology what's going on. This is just a little text version. If this is more simple for you guys to understand, then you can take a couple seconds to take a look at that. But I'm going to move forward. Let's see. Moving to each router has the exact same. So this is telling you a couple use cases as far as what I was describing earlier. If each router has an individual IP, but they take over for the virtual IP, or shows you a scenario with sort of the load balancing that I was talking about earlier that you can sort of achieve using VRRP. It says the following figure shows a configuration with two virtual routers with the host splitting the traffic between them. So this can be achieved with DHCP, or you have a certain amount of hosts on data VLAN 1, certain amount of hosts on data VLAN 2, and they can both be using the separate paths, and you can sort of achieve some load balancing that way, but still have that backup or have that redundancy if necessary. I really wanted to dive into the protocol. So the purpose of the VRRP packet is to communicate to all VRRP routers the priority and state of the master router associated with the virtual router ID. When VRRP is protecting an IPv4 address, VRRP packets are sent encapsulated in IPv4 packets. They are sent to the IPv4 multicast address assigned to VRRP. And in just a second, I'm actually going to pull up a packet capture of this work, and we'll get VRRP packets flowing and have you guys take a look. When VRRP is protecting an IPv6 address, VRRP packets are sent encapsulated in IPv6 packets. They're sent to the IPv6 multicast address assigned to VRRP. So here is the packet format. And I don't know about you guys, but every time I look at one of these, I'm like, what the heck does this mean? I'm scratching my head. I'm like, what the heck does this mean? So what I wanted to go ahead and do is I wanted to go back to the Eve topology. I wanted to fire up VRRP on one of these routers, and I just want to go ahead and take a look at one packet. So just so we can sort of follow along and see what it looks like in Wireshark. So I'll go ahead and get on the interface that I have destined for VRRP, and we'll see what's on there already. I have nothing. I just have the IP address, which is great. So just like the HSRP configuration, we're going to go ahead and just use the VRRP keyword, and it's going to prompt us for a group number. So we'll use 17 because this VRRP relationship is going to be happening between router 1 and router 7. You see what I did there? And we are going to make the IP address 192.168.2.1, which neither of these share, and keep that in mind. So now that that's going, we see it's immediately stayed in it to back up. It's going to promote itself to master because there's no one else talking, right? So we're going to go ahead and close this. Now that we're generating packets, we're going to let's go to switch and let's capture Ethernet 1. And let's see what we got going on here, guys. And we see some packets. So all I wanted to do for here is I just wanted to show you guys one packet. Okay. So let's pull that up. Let's pull that up. And it's in our display is too small. Still too small. No, we don't need that page anyway. Haha. Okay. So let's pull up the packet next to the RFC. And this should help us out, decode it a little bit, guys. So you see here, all this jazz right here, the IPv4 or IPv6 field. In this case, we're using IPv4. So let's go ahead and take a look at what would actually be here, right? So IPv4, it's router 1, so it's sourcing from that primary address on the interface, like we just read, right? And it's going to the destination address is a multicast address that is specifically reserved for VRRP, so that's 224.0018 or 18. You guys can see that again down here. You can see the specific protocol identifier. IPv4 protocol is 112, and now we'll get into some of these other guys down here. So you see version here on this side of the screen. I'll highlight that for you guys. And then you come down here, sure enough, shows the version. And this is directly in this order, so if you just kind of circle this around, it's already in the right order, which is nice. But seeing it in a packet capture gives you that extra warm and fuzzy, at least for me, to sort of put it together in my head, what kind of data is in the actual payload of the protocol. The virtual router ID in this scenario we know is actually the group number or the VRRP number that we assign to the interface with the IP. The priority is default is 100, so that's no different than HSRP, right? So I promised you guys that we would take a look at this from the perspective of how is it differentiating itself, so I want to stay true to that. No authentication is set up. You see here the next is checksum, so we got the checksum and then the actual addresses that it's responding for. So this is 2.1, right? Everything is good. So let's keep going with the RFC. I know that you guys love packet captures, but let's keep going here. So now we've taken a look at the packets. It goes again, tells you the destination multicast address that's reserved for VRRP is 224.0018. This is a link local scope router. Even though the TTL is set to 255, you can see that here on the right side of the screen. This cannot be forwarded. Routers are not going to forward this multicast. It doesn't matter what the TTL is. The TTL must be set to 255 too. So this is actually a requirement for a VRRP router to think that a VRRP message is like legit, right? So if it sees one that is not, it actually tells you here, right? This is straight out of the RFC. It must discard the packet. It says the IPv4 protocol number is 112. We already learned that, but there you go, reinforcing it straight from the RFC. And then it tells you again the source address is for IPv6 is the link local address, right? So it should be that FE80 address. The destination address for IPv6 is always this, so the actual end is right there. Boom, 12. Same thing. The hop limit must be set to 255. Hop limit TTL. Same thing. So let's get in here. The type field specifies the type of this VRRP packet. The only packet defined in the version of in this version of the protocol is an advertisement, right? A virtual router ID. The virtual router ID identifies the virtual router this packet is reporting status for. So the virtual router ID is actually the group number or the virtual router that you set up in between them that they're agreeing on. The priority. So this is pretty cool. So I remember I told you guys I was going to help you guys differentiate these protocols. So this is why I like to just dive into the RFC because it just puts it in plain English for you. It says, I'm going to read this to you guys. So the priority field specifies the sending VRRP router's priority for the virtual router. Higher values are higher priority, right? So the same thing, same sort of concept as HSRP. This field is an 8-bit unsigned integer field. The priority value for the VRRP router that owns the IPv4 address associated with the virtual router must be 255. Now you remember I told you this whole new concept of having the same IP address on the physical interface as the virtual IP. Well, this is what this is talking about. So I guess that this is a thing. I've never done it because I've never, I never even knew that this was a part of the VRRP protocol. So maybe if I knew that, I would have. Is if you have, let's go back to the topology really quick. So I can show you. So in this case, if we have router 1 and his address is 192.168.2.1, and then we have router 7 as 192.168.2.70, and we make the VRRP IP, when we do VRRP 17 IP 2.1, since that's shared on router 1, we're actually it's going to automatically make the priority 255. It's pretty cool. Let's check it out. So I can prove it to you guys. So we'll do a do show run int eo1.2, and you see the VRRP IP is 2.1, but you see the physical IP address is 2.10. Now if we do a do show VRRP, you can also see that the priority is 100, which is default, right? And we are the master. So if I change the IP address right now to 192.168.2.1, which is the virtual IP, you're going to see something happen. What happened, right? So we went through the whole process again, and we became master. It's like, okay, so we changed the IP, maybe we need to, sort of renegotiate. Maybe if I have a lower IP, maybe there's some changes that need to be made. But I want to show you guys what happens in the background. So, no, not do show run. If you do show VRRP again, you can notice that the priority is set to 255, right? So it's like, okay, now I'm 255 just because I'm that IP. And if you didn't ever know this and you happen to do it, it would automatically become the master, even if that wasn't advantageous for your design. So pretty cool. I was like, well, what if I set the other one to 255? So I'm speaking HSRP language there. So if I do VRRP for the group number 17 and I want to statically set the priority, I did a question mark and I was like, oh, I can only set it to 1 to 254. So this isn't something that you can even statically assign. If it shares that IP address, it's automatically going to promote it to the highest level possible, and there will be no other router that is able to, achieve that level of coolness or whatever you want to call it as a router, because you can't have conflicting IPs on the same LAN. So pretty cool feature. And when I started diving into this, I really started realizing where VRRP sort of stands out. And you notice that you can only go 1 through 254. So diving back into the RFC, it sort of explains that as well. So it says VRRP routers backing up a virtual router must use priority values between 1 and 254 decimal. The default is 100. The priority value 0 has a special meaning, indicating that the current master has stopped participating in VRRP. This is used to trigger backup routers to quickly transition to master without waiting for the current master to time out. So pretty cool. We're actually going to lab this up, and I haven't even captured this in Wireshark yet, so you guys will see it with me, and we'll see if we can sort of capture that when a failure occurs or something like that. If it actually does send out a packet with a priority value 0, I'm interested to see that with my own eyes as well. So I think that's enough for right now. I think the rest of the RFC would probably be better covered in another video with some of the more advanced features of VRRP configuration. They'd probably tie in well with those. So I think we're going to stop there, but I do want to get back into the topology, get into some more configuration, get VRRP working, and take a look at the functionality of those priorities, and take a look at some packets. So let's go ahead and do that. So We are back on our topology. We are going to take a look at what we have configured just to make sure that we're all on the same page. So we have this guy Sharon, so his priority is going to be 255. That's going to make him the master, and he should be no shut, just making sure. And let's go over to R7 and see what we got over here. So we have nothing set up on R7, so there's no VRRP conversation going on. So before we start the two-way conversation, let's do a, I think we already have a capture running, so let's go ahead and close that out. And we'll start a fresh one. We will start a fresh one. Okay. Guys, I hope you guys are enjoying this. I promise I'm going to get better the more I do this. It has taken a lot out of me to gain the confidence to get on here. You know, I'm sort of someone that wants to make sure everything's perfect, and I'm paralyzed until I can make sure everything's perfect. So just bear with me, and I promise that, you know, video after video, I promise to get better and continue to improve my processes and stuff. So we got Wireshark going here. Once I verify that this starts running and we're actually capturing packets, I'm going to go on R7 and make sure that thing is doing its thing. So let's close this out. Let's go back on our router 7. And let's configure this bad boy. Boom. So we know this guy's going to be the backup, right? He doesn't own the IP address. We've read in the RFC that whoever owns the IP address is pretty much the active or the master, no question about it. So we'll do a do show VRRP. It says the state is backup. The virtual IP address is 192.168.2.1. The virtual MAC address associated with that is 0111. So 0005E000111. And we're going to break this down as well. Because I was interested in that. I was like, where does that come from? I want to know about that. The advertisement interval is 1 second. Preemption is enabled. Another differentiator of VRRP, preemption is enabled by default. So whereas in HSRP, you have to go sort of give the router the confidence to say, well, I'm a higher priority, so I should be the best gateway out there, and you guys should be using me. VRRP, it's a little bit different. The only one speaking is the VRRP master, so preemption is enabled by default. The backup is sort of just there, it's listening. As soon as it hears that message, I'm assuming where the master says I'm 0, you know, I want to be fully released, the backup router just immediately takes over. So it's that constant conversation, and he's ready to take over whenever need be. And there are some timers involved with that you can adjust, but that's pretty much the gist of it. The priority on this bad boy is 100. That's the default, and it goes ahead and tells you that the master router is 2.1, right? It's not the physical IP, and its priority is 255, so you can enumerate that's the physical IP just from that. So pretty cool. So let's go ahead and take a look at the packet capture. So if you notice, guys, I've already configured everything that needs to happen between the both of them. And if you remember the HSRP video, and I encourage you, if you didn't watch it, to go back, just for the simple fact that you can sort of compare it to this video, is that we were flooded with advertisements from both. Even if they were an inferior advertisement, the standby router in the HSRP scenario is sending out its advertisement. It's sending out as advertisement, you know, throughout that interval. It doesn't matter if it's inferior. You see here nothing but 2.1s, 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 right? So only that active is sending. So let's go ahead and stop this so it stops moving on us. And let's go ahead and take a look at what one of these announcements look like. And I want to make sure that you guys are actually seeing all of this, so I'm going to move this just a little bit, okay? So let's take a look. Remember guys, these are coming from router 1. So it says IPv4 header right here, coming from 192.168.2.1. That's a physical address, right? Not the virtual. Remember, we're sharing it, so it's coming from the physical address. It's going to the destination address, which is a multicast address reserved by IANA to for VRRP. You come back down here. It's VRRP is IP protocol 112. It tells you the source and the destination again, and now we can dive into the actual payload of the VRRP packet. So it says the version, we went over in the RFC. The virtual router ID is the group. The priority is 255, and notice that this is cool. Wireshark actually tells you this VRRP router owns the virtual router's IP address. So there you go. So if you were just casually doing this, you could have just not even read the RFC, but whatever. No authentication, and it tells you the group address. So pretty cool. So what I want to do now is I just want to show you the preemption feature that is enabled by default, and then we can wrap things up. The only way to do that is to take off the shared IP address, to take this guy back down to the default of 100, which will verify, and then we will decrement its priority a little bit lower, and we'll show the automatic preemption. So here we go. So the only way to take this away from 255 is to change the address to my initial design, which is 192.168.2.10. 255.255.0. VRRP is going to do its thing again, and we will probably say backup this time because you know they're both talking right now, and they're like, hey, we're both 100, but router 7's got the higher IP at .70. So we will show VRRP just to make sure that we are backup, and virtual IP address is the same, virtual MAC address is the same, and let me make sure we're capturing for this too, because I think this is important too. I want to show you guys just in the event of the preemption, I want to see a little bit how that works out. So let's go ahead and close that. So it's telling you that router 7 is the master and the priority is the same, right? So pretty cool stuff here. Let's close this for a second, right? So well, that's the HSRP host. This is a really cool thing that I wanted to make sure that you guys captured. We come on the host. Oh no, I think we're gonna have to restart this guys again. This is gonna be a common occurrence, I think, guys. It's not a big deal. We have DHCP set up on the switch to hand this guy a new IP, so we should be able to Dora, and we should be able to get a new IP. It should be the 2.200 IP. We should be able to ping 3.3.3, and we are golden, guys. Remember, this host is specifically attached to the VRRP logical topology. So now that we know that we can get all to 3, let's go ahead and trace it. Let's make sure that router 7 is indeed our gateway that we're using, which it is. There's the local IP of router 7 right there, and I want to get in here. Now that we know that that packet flow is actually going to router 7, I want to show you guys what happens in the switch. So obviously, if that packet is going to the switch, and the only packets for VRRP that's coming from router 7, right? So what happens is when the router 7 decides to own that 2.1 address, it's actually sending a gratuitous ARP out for it, right? But what happens is, I did exit. If we look in the MAC address table of this switch, you're going to see that, remember that 0005 echo 000111. You're going to see that address, and you notice the port, the outgoing port, is Ethernet 03. And I want to really make sure you guys get this, because this is the key to how this is all working in the background. So I'm going to just circle it for you right here. So E03 right there. And then that's this guy going to router 7. Okay? So what's going to happen is when we initiate a failover by, we can either decrement this guy down to priority 99, or we can, promote this guy to 101. With preemption enabled by default within the protocol built in, what's going to happen is as soon as this guy sees an inferior message on the LAN, because this guy's the only guy sending right now. Once he sees an inferior message and he says he's 99 or he's 100 but I'm 101, what's going to happen is this guy is going to start, he's going to send his advertisement, and then he's going to send a gratuitous ARP. And as soon as he does that, this guy is going to see the superior message, and he's going to go, okay, I'm definitely the backup. This guy wins. And then he's going to stand down pretty much. This guy's going to send the gratuitous ARP. And the point of that is so that this switch actually changes the MAC address table, right? The CAM table. So it's for station learning purposes, right? So we're going to show you guys how this works. So just remember that right now, that virtual MAC for that virtual IP is on Ethernet 03 facing router 7. Okay? So we verified the packet flow. We verified that the switch has learned it on that upstream port going to router 7. So the layer 2 topology is built. And let's go ahead and show you guys this. Pretty cool stuff. Oh, we said we were going to capture this. So let's make sure we do that. And I just realized that the whole time I was telling you that router 2 was going to take over router 7, that is not going to happen because that is a part of the HSRP topology. So I apologize, guys. The router 1 is the one that we're actually going to be worried about here. So we're going to capture on Ethernet 01 facing router 1, which is in the middle. And once we start capturing, I'll go on there and we'll promote this guy. So you see all the packets now are coming from 2.70. He's the only guy talking because he is the boss right now. So let's get into router 1. Let's go, make sure we're in the right interface, and we're going to go VRRP 17 priority 101. This is just 1.0, guys. You're going to get the log messages, right? Because that's part of the protocol. He's going to become master. We can do a quick verification. He's become the master. Let's quickly go over here. Let's stop this because the job has already been done. I can go show you guys what's going on in here. So 2.70, blah 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 blah, right? And then all of a sudden, you just see this ARP. What is like 2.70, and then it's like boom, broadcast, gratuitous ARP, right? And in the packet capture, there's no mechanism to be like, okay, who's sending this out all of a sudden? This wasn't happening, right? Because you look at the MAC, and it's like, okay, this is coming from the virtual MAC. Okay, that doesn't tell me anything, right? There's no real true way to figure out how this works until you put all of these pieces together: the RFC, the packet capture, the logs on the terminal. You got to put it all together, and then you got to get into the switch, right? So it's coming from that virtual MAC, we know that. And then all of a sudden, all that we see at the top is this guy, 10. He just starts talking, and his announcement comes in, and he goes, I'm 101, right? And it's I'm 101, right? And it's just like, okay, you're 101. Same thing. We see another gratuitous ARP come in. You know, the whole point of this is to populate that layer 2 topology, right? So we see the gratuitous ARPs, and now we see nothing but router 1 talking on 2.10 address. So we're like, okay, cool. And without even sending any other traffic from the host, right? We haven't initiated any other traffic for it to ARP and find it and do any of that, right? But we go through the switch. We're going to do a show MAC address table. And guess where that virtual MAC is now, guys? It's on Ethernet 01. And it learned that from the gratuitous ARP that the router initiated when it took over. Pretty cool, right? So the final step to verifying this, guys, is getting into this VRRP topology host, and we are going to just go ahead and ping, make sure we have still have connectivity. And the last verification for this test is to just trace, and the next hop is going to be router 1. And it is 192.168.2.10. Guys, I hope I stayed true to my promise to you, and that was to go over VRRP in some detail. I think it was a considerable amount of detail. I wanted to let you guys know what the RFC says, right? not just what I say, but what does the RFC say? It's very important. One of my mentors and close friends, Narma Kacharian's, I really look up to him because he just has a no BS way of approaching studying and learning these topics. And for my entire career up to this point, I have always avoided, like the plague, reading the actual RFCs. I would watch video after video after video. I'd read book after book. All these expensive things that, I'm spending hundreds of dollars on books, but I wouldn't go approach the RFC and just tackle it. So I know that there's people out there like me that are dealing with that fear, and I'm just trying to help out with that a little bit and make it more approachable. I hope that I showed you guys enough on the configuration side and was able to differentiate VRRP at least at a very high level to HSRP and give you guys some good background knowledge. So I hope that you guys will lab this up. If you have any questions, feel free to contact me on LinkedIn or at john@ethervest.com. And again, I just want to thank you guys for supporting. Have a good one.